Good afternoon, everyone, and welcome to ASA's safety webinar on confined spaces. I'm Michael Place, Training Director for Dakota Supply Group and the Chairman of ASA's Safety Committee. Each month, the Safety Committee publishes articles and toolbox talks on a variety of safety-based subjects. These can be viewed and downloaded from the ASA website at www.asa.net. Also available on the ASA site are recordings and downloads of previous webinars. All of these items are available free to our membership and to the public at large. To view these resources, look for the Safety Resources link on the ASA homepage, which is located at www.asa.net. If you have any problems, contact Dan Hilton at the ASA for assistance. At this time, I'd like to draw your attention to ASA's supplier partners shown on the screen. They are very important to the work we do, and they are very helpful in every way to our committee. The Safety Committee would like to thank them for their industry leadership and for supporting our committee and these webinars. This webinar is being recorded for later viewing. Everyone that registered for the webinar will receive an email notifying them when and where the replay of the webinar is available. Attendees will also receive an emailed link to its location. All attendees are in mute mode. To submit a question during the presentation, you can enter it in the chat window. Before you send it, be sure your setting is set to send the question to our organizers and the panelists so we can see the question. Questions will be answered at the end of the presentation as time allows. Also, an FAQ document with all questions and answers will be posted on the ASA site along with the replay of the webinar. Other related documents will be posted in that location as well. I would now like to turn our attention to today's event. Today's webinar is presented by Brady Corporation. Brady Corporation is an international manufacturer and marketer of complete solutions that identify and protect premises, products, and people. Its products help customers increase safety, security, productivity, and performance, and include high-performance labels and signs, printing systems and software, and safety devices. Today's presentation title is Confined Spaces. Our presenter for this webinar is Andy Mueller. Andy Mueller has a Master's of Science degree in Occupational Safety, Health, and Environmental Management and has 15 years of experience as a safety professional leading the implementation of safety management programs. He has extensive experience authoring, providing training, and implementing best safety policies and procedures focused on the minimization of safety hazards. In total, Andy has over 25 years of experience in manufacturing. A full bio of the presenter will be posted with the webinar documents on the ASA website. I'd now like to turn the presentation over to Andy Mueller. Andy?
Thank you, and welcome. I'm going to go right into confined spaces. So why do we do confined space programs, and what is the purpose of it? Some people would say, oh, because OSHA says. It's deeper than that. It's because people get hurt or die associated with confined space entries, especially confined space entries, because they don't understand the hazards. So I have one example here. 37-year-old worker climbed down into a rail car to clean out corn steep residue and was overcome by dangerous hydrogen sulfide gas. A 29-year-old tank inspector who attempted to rescue the first worker succumbed to its gas exposure as well. Neither worker made it out of the car alive. Misunderstanding of the hazards of the gas itself, where the gas comes from, and the process for entering into that confined space itself. So what is a confined space? So OSHA classifies it as these. First and foremost, is large enough for workers to enter and perform tasks, meaning I can get into it. A confined space isn't necessarily something where I can stick my hand into or my arm into, which would fall under lockout tagout. But if I can enter it, full body, climb in, crawl around, regardless of the size, you also have to take into account that there are varying sizes of workers. So you have to take that into account when analyzing a confined space, which we'll get to in a few slides later. The next is has limited or restricted means of entry or exit. This means something of small size. I have to climb in, I have to climb down. Anything less than a standard door only has one way in and one way out depending on the hazards of the space, and then is not designed for continuous occupancy, meaning it wasn't designed for me to live in it. Simply put, workers may require to enter a space that is not designed for people to perform maintenance and tasks. So drivers for improving a confined space program. First and foremost is the regulatory side, obviously. And there are different regulations. OSHA has its own regulations, but they go by NFPA and ANSI standards for some of the things that they refer to, typically not writing necessarily their own regulations, depending on the situation. Some of the other issues, lagging indicators, meaning accidents, near misses, citations, or in the example I showed, somebody died. I tend to put the safety of employees over the regulatory side because OSHA doesn't exist to prevent injuries. It exists from a legal standpoint to make sure that companies are held accountable for their safety actions. And then the leading indicators, audits, confined space inventory, safety training, all the practices which I'm going to talk about in this presentation that lead to safe entry into confined space, able to perform work safely, and also prepare for the unknown in the event that a safety incident or accident or something unknown happens while workers are doing work in that space. So some examples of confined spaces, and this is definitely not a comprehensive list for entry into confined, or for types of confined spaces, excuse me. This is a simple list. Very many more that could be added to this list. As we go out and do evaluations, I've probably seen 50 to 100 different styles, all of which have their own characteristics, because you'd think one tank is alike, but in lots of cases they're not. So what is a permit required confined space? So a permit required confined space, because you can have a non-permit confined space, but a permit required confined space contains one or more of the following. Contains or has the potential to contain a hazardous atmosphere. Could be particulate matter, could be a gaseous material, could be something that requires an oxygen, breathable air tank or something like that, depending on the hazard that's in there. Contains a material that has the potential for engulfing an entrant. Corn silos, grain silos, sugar, flour, anything that could flow, especially if it's a flow, the flow of it is into a funnel down configuration and then goes down into a spout that discharges it. That's going to cause it to suck you in almost like quicksand. Has an internal configuration such that an entrant could be trapped or asphyxiated by inward and converging walls. It's not so much because of the angle, it's if you fall into something that could trap you and it squeezes you in, it fixates you because you inhale and exhale, and once you exhale and you release all that pressure in your lungs, it's now going to asphyxiate you because now you can't breathe back out because you're going to slide further down into that internal configuration where walls or things taper down, and then contains any other recognized serious safety or health hazards. Some people look at this as, oh, that's OSHA's way to catch everything if they deem it a safety and health hazard. What I say to people that answer me with that is, you have to evaluate all the potential hazards, and you can't necessarily list all the hazards. And from a best practice standpoint, you should make it a permit required confined space because of the hazards associated with it, not just because OSHA doesn't have it on the list and define it as a permit required confined space. So the first step in classifying spaces, and this is where sometimes the list gets confused even within programs as we evaluate programs, it's the classification of the spaces themselves. It's actually a two-part process, classifying spaces and then identifying hazards associated with the space. The first is just determining if it's a confined space at all. So for this set of criteria, space large enough to enter, limited or restricted entry or exit, or not designed for continuous work or occupancy, you have to answer yes to every one of those. So all of them have to be yes, and then it becomes a confined space. If you answer no to one of those criteria, it's not considered a confined space. Then you move down to, okay, now I have to determine, is it a permit required confined space or a non-permit required space? And that uses the same criteria that I showed on the previous slide. Hazardous atmospheres, engulfment hazards, configured hazards, or other recognized serious safety or health hazards. Those are OR functions. So if you hit one of those functions, it immediately becomes a permit required confined space. Don't stop on the list though, because, and we'll get to this in a little bit, you have to determine all the hazards associated with the space. You know, if I determined it's a permit required confined space because of engulfment hazard, I have to evaluate all the hazards associated with the space, which I'll get to in a little bit. So the first step in the process is really full organizational engagement. And for those of us or those of you that have worked in safety, you understand that dynamic because you're not necessarily the person who gets the money from, you know, you have to get money for it, but it's not necessarily your budget because it's company owners, whether it be private or public, or publicly owned. It isn't just an open checkbook for obvious reasons. We're all running businesses. So the more buy-in, the better. Included on the list, thought leaders, consultants, or even internal experts, technical experts when, and I've even run into this in my experience, the best collaboration is to have a network of people you could go to when you run into those unknowns. Because a lot of times in an organization, you may be the only safety person and there isn't an expert you can necessarily go to internal to your organization. And then it's really the workers who are actually doing the work, getting right out there and understanding what they're doing, teaching them to recognize hazards and how to interact with those hazards, to the point of you need to know what they're doing when you're not looking, number one, and number two, know that they understand the hazards and work with those hazards to prevent things from happening, not because they're going to lose their job or get fired or any of those issues, but because if something happens to them or their coworkers, it really changes their lives. So another way of looking at it, program implementation from the top down, trying to do it as a grassroots effort takes a lot longer, may not be as effective if you have a buy-in from everyone, starting at the top with executives down to managers, supervisors, and then the front line. This is sitting in an office and writing a confined space program and doing the analysis without input from others is about 50 to 60 to 70% deemed for failure because nobody's going to follow it, and then the impression that's sent is, oh, we're only doing this in case OSHA comes in or to protect the company or to protect someone else, which isn't really the case when it comes to safety because safety is about especially the frontline employees. The next is provide positive feedback and recommendations for improvement all across the board. Buy-in to safety is organizational, not just one or two groups of people. And then, again, need to understand what employees are doing when nobody's looking. And not treat them like kindergartners as well, where we dictate everything that they have to do. Because then you get people that aren't necessarily thinking about what they're doing because they're basically told what they should do or not do. The next is to actually have a written confined space program, and this is an OSHA requirement, but also a best practice requirement. If you already have a program, create a dedicated team to audit your program annually or as conditions change. Don't wait for that annual review to change it because you're going to have a gap in time depending on when your last audit was that the practice has changed. And then build in processes for routing corrective action and approvals. One part of a management system, if you have a safety management system program, who approves it, who reviews it, does everyone understand it, what corrective actions had to be made and why. If you don't have a program, this is where the work starts. Gather all of your documentation and knowledge. And some of it may not even be available, so you have to list confined spaces and then do the analysis piece. And then list a volunteer army, safety committees, things like that, external assistance if needed to come in and help you write the program. Activities for this team are, what's our current state? do we enter confined spaces, or what is our process for entering confined spaces? Surveys of employees, what work did they do? What hazards did they encounter? What issues have occurred? Data collection on confined spaces. That's the most important piece, because your program shouldn't just be something that is pulled off the internet and you change the company name in it and it's all good, because that may not cover things that are specific to the facility that you work in. The next is program building. What does it look like? Again, you can use a template, but a lot of the things in there, terminology, templates, visual devices, may be local to what you have on site. Training, how do you do training, contents, tools, guidelines, things like that, specific to the site. Entry equipment needed, an atmospheric testing gas meter. In some cases, you get a 4 or 5 gas meter, but say you have ammonia, chlorine, other types of things that you have to test for, you may need additional gas meters and atmospheric testing equipment to be able to understand the hazards inside of a confined space. And then the last one is emergency response and rescue procedures. One of the more important things, but a lot of times gets missed and then gets put in place after an event happens. Most important part of it, even though your program hopefully prevents things like that from happening. So then the third step is really the inventory assessment and classification. This is where you identify potential confined spaces using the two-step process. Go and identify the confined spaces, document your inventory of them, then follow it right up with a hazard assessment. Perform that hazard assessment to determine permit required versus non-permit required using the criteria. Once you've done the hazard assessment, it doesn't stop there. The next portion of the hazard assessment is now you have to determine the entry requirements for each of the permit required confined spaces. And there could be a duplication depending on what types of spaces you have, or they could be multiple types of confined spaces, again depending on the types of spaces you had. You have to maintain that written inventory of confined spaces with the associated assessments. And those assessments drive what you create as the procedures for entry. And then the last part of it, documented emergency response plan specific to each space. Again, because of the variability of spaces, it's better to have a plan up front than trying to figure out, okay, what am I going to do now when somebody needs help from an emergency standpoint. You want that to be a rapid response for the sake of not endangering people and saving lives in some cases. So then we move on to the permit itself and the assessments. So if you have a permit required confined space, it's obvious you need a confined space entry permit. Some companies create them as a general permit and then look at the assessments to determine the specifics they need to do to enter a specific space. Other companies create specific permits specific to each space, because then it has all the hazards and all the assessment criteria on that permit, because when you enter that permit space, depending on what you have to encounter from a hazard standpoint, that dictates entry procedures. Do I have to wear a harness? Do I have to wear a retrieval line? Do I have to wear a respirator? Do I have to ventilate this space? What testing do I have to do? What do I have to test for? And levels and things like that. All the instructions based upon the hazards associated with entry and work inside that permit space. And you can see the list of items, which I won't read through them all, but you can see the list of some of the typical items that are on there. Again, a lot of times typically customized to a specific site or specific manufacturing companies, sometimes tied back to their culture as well. So when I talk about confined space and assessments, we usually talk about a best practices approach, not necessarily OSHA requirements, because OSHA's requirements are minimal. Again, like I said earlier, the best practice approach, true prevention of injuries and potential death to employees or anybody entering the space, could include contractors. So stored electronically, access by as many people that can. What happens there is a lot of times electronically, if changes are made, everyone has access to them. But if they're printouts of documents and some changes were made, and they could be big changes like changes to a hazard assessment or a permit, and someone has an old one, they may encounter a hazard inside that because somebody changed what was inside of that confined space, changed it from, say, water to sulfuric acid or something of that nature. They wouldn't go in and assess for sulfuric acid if they had the old permit and hazard assessment because they would just think it was water. Identify and document hazards, isolation methods, acceptable entry conditions, and protective measures. So that's PPE. That's what do I have to wear, a harness, a retrieval line, some sort of system to pull somebody out of something. You typically see someone enter a sewer, especially in the city. They have a tripod over with a pulley or hoist system, or some of them motorized, so they can pull that person out should something happen. Isolation methods. Confined space can be one of the most comprehensive safety programs, and I say that because it includes lockout tagout, which is a separate program, and it includes hazard assessment previous to entering it to understand the hazards that are in there that determine, do I need a respirator if I'm in and it has some sort of fume or some sort of particulate or some sort of hazardous thing that I could breathe in or could affect me, which also then determines PPE. It's obviously tied to the permit process. And then critical that these are reviewed and updated annually for changes. But at the same time, don't wait for that change to happen annually. If there's changes made, make sure it's a live system that changes are made, having a review process for new equipment, new hazards, whether it be from a contractor, engineering, those types of things. And then emergency response and rescue. Again, this gets missed some of the time. You have to determine the emergency response process and who does it. Is it an internal team? Is it external emergency response professionals? Is it a combination of all of those? And then if you do have that emergency response process, or which you should have, do training and emergency drills, because you want to make sure that everyone understands how to work the equipment if they have to work equipment, if interaction with the emergency response team from an external if they come in, or if it's a non-entry, which I'll get into the types, but if it's a non-entry and you rely on emergency response professionals to assist, what does the internal team do? Must be available while authorized entrants are in the space as well. Anytime someone enters a confined space, whatever that emergency response process should be on standby should something happen, whether it be an internal team or an external response professionals. Because as you read at the bottom, deaths often occur when attempts are made to rescue an entrant. The rescuers become victims as well. And I refer back to the first story I went through. Everybody wants to help, but when you become a victim, you're not really helping yourself or them at that point in time, because you really can't save them either when you become ineffective. So the rescue techniques, really three basic types. It's non-entry, which means there's probably more equipment that a person's going to put on, depending on the space that they're entering, to be sure that you can retrieve them from the space without entering the space. You can't rely on self-rescue, having someone rescue themselves. There are self-rescue things you can put on them should something happen that they can rescue themselves, but you can't rely on that as the sole means, because if they pass out, something health-wise, even personal, happens with them, there's no way for you to get them out if it's a self-rescue system. Entry by others, whether it's from an emergency rescue service. The critical portion of this is to not say, oh, we'll use external rescue, and then not contact the local fire department or rescue service if there is one located near your facility to determine, hey, we have an emergency, we need you to come rescue with confined space. You have to evaluate them and determine their capabilities, and this is even listed within the OSHA regulations, because you don't want to get in a situation where you call the fire department and say, oh, we need them to rescue, and you write it in your program, the fire department gets there and they don't have the capability to even do it, and then they have to call an external service. After that, it tends not to be necessarily an emergency rescue, it tends to be emergency, or not even emergency, but recovery of victims at that point in time. And then entry by trained company employees. And there's a timing thing to this as well, is based upon hazards, do you have the amount of time to wait for the emergency response to get there should an event happen, all classified based upon the hazards. Again, another important step in the analysis process for entry into the space, and then how do you get a person out should something happen. For that internal team, you got to have someone who is at least one of the members certified in CPR and first aid. They have to be trained on the equipment. Those are all pretty self-explanatory things. And then have to have knowledge of all the confined spaces and their associated hazards. Because if they aren't knowledgeable of the confined spaces, don't even know what the confined space is, don't know internal configurations, or even understand the hazards, that's where they become a victim themselves. Emphasized earlier, practice and emergency drills. Run them as often as you need to, because it should run like a well-oiled machine. On top of that, for any of us or any of you who have responded to emergencies, there's an emotional factor to it. There's an adrenaline factor to it. And it has to almost become instinctual. You don't want someone who freezes at the sight of blood, or freezes in the event of an emergency, or breaks down and becomes a victim themselves. You need to make sure that they can do the process. And then the coordination with that external emergency rescue personnel. Even if they aren't qualified to go into a space, you call an ambulance in, there's got to be some coordination with them as well, because they're going to be responding to aid in this certain situation. The last portion, which is the evaluate and sustain, annual review and training. This is where, well, we've trained on the confined spaces. It doesn't hurt to review it, especially since it's such a critical function, especially depending on the hazards of confined spaces. Make sure there is a process for keeping up with changes to equipment. And this encompasses more than just confined space, but any changes to equipment, whether it's, taking a permit required confined space and making it a non-permit required confined space, or something's changed on the equipment where, if you go through the first 3 criteria, the thing that has to take place when there's changes to equipment is you have to redo both assessment processes, evaluate it to determine if it's a confined space, and then determine the hazards if it's determined that it's a confined space. You have to redo the hazard assessment. You can't just leave it in place. Changes in hazards. It could be both ways. Hazards are gone, but you still, again, have to revise that hazard assessment. Or if there's changes in the hazards and they're worse, you have to redo the evaluation and not allow entry at that point in time. Review permits and monitoring data. So first and foremost, review of the permit should make sure that the practices are being followed as far as entry, and make sure that they're doing the steps properly. Because if you miss something, that's when something happens. It may not happen 1 in a million times, but that 1,000,001 time is when somebody dies. It becomes a critical issue. And then monitoring data. A lot of the newer gas meters now record data and stuff like that, but you can't rely on that. One of the requirements of the entrant who is standing at the entrance to monitoring what's going on should be monitoring that data, because if they see any spikes, they can then give that order to evacuate the confined space should something happen or something goes wrong. The best thing to have in a space is to have a remote connection and have a device on the person who is in the space, because then you're getting real-time data where that person is at, as opposed to just sticking in a probe. And in some cases, companies don't buy the lengthy hose to send that probe in. They'll just put it right at the entry. Well, if the person is 30, 40 feet away from the entrance, you're not really measuring what's going on in the space where the person is at. Observations and practices. This is where paying attention to work, monitoring what's going on with, and training supervisors, the confined space entry supervisors, those personnel, other employees, what to observe, what practices, anything they see. Not tattletale to get people in trouble, but we need to fix them so we don't have an incident or an accident or a potential death. And then review your incidents, accidents, and issues. Review them from a true root cause analysis standpoint, not just Joe did this wrong, Bob did this wrong. It's hard to determine what actually happened and prevent something to happen in the future with the same practice if all the issue was, well, that was Bob's issue because he didn't do it right. It really doesn't give enough detail into what caused the issue to actually occur so you can solve the problem. So at this time, that was 30 minutes, about 30 minutes. Any questions?
Okay, Andy, I do have a question here for you.
Yes.
The question is, how often do I need to calibrate my gas monitor? Is there a regulation I can review that provides guidance on this subject?
So every time you turn on a gas meter, it should be bump tested, which is hooked up to some sort of a system to make sure that it's properly working. And then most of them now, but with, I believe it's 60 days, I forget the time frame, but 60 days, most of them have an automated timer on them that the meter won't turn on unless it gets calibrated on a regular frequency. I can't remember if it's 60 or 90 days, but a short time frame.
And there's a second question related to gas monitors here. What features or specifications should I be looking for when purchasing a gas monitor?
So there's gas monitors out there that basically if you ordered a 4-gas monitor, it has standard stuff on it. One is oxygen level, and there's ranges for those. There's carbon monoxide, hydrogen sulfide, and then a flammable gas curve, which you can mimic propane or methane or natural gas or types of things like that. A lot of times they're set to methane by default. The oxygen portion, I think, is where people sometimes get confused because there's a lower limit, obviously, for breathability, but they sometimes ignore the higher limit. And especially if you're going into a confined space to do welding, if you have oxygen higher than 26%, it promotes a significant amount of combustion, adding oxygen to a fire, adding fuel to a fire. So it's critical that you have at least those 4, because those are the ones where it's beyond just putting on a respirator. Beyond that, if you have some sort of other gas in there, whether it be ammonia, an organic gas, chlorine, those types of things, you could buy 5-gas meters that have those detectors, whether it be a PID detector or chlorine or ammonia detection, or you have to have a separate meter that detects those. The other thing that gets missed is particulate levels. If you're going to have someone enter a space that has something in it where there's a respiratory issue because of, say, sawdust or sugar or something of that nature, where it's going to be airborne, you either got to ventilate the space, provide them with the level of what's in there, and you have to test for all that before you go in, and then continuously monitor it while people are in the space. Great question.
Okay, and I see one more question here, so if there's any other questions, please send them in here shortly. The next question I had here was related to the NFPA and ANSI standards you referenced at the beginning of the presentation. The question is, can I rely on OSHA's letters of interpretations and the OSHA regulation to be sufficient, or should I investigate and review the NFPA and ANSI standards as well?
So you should investigate and review the ANSI and NFPA standard as well. OSHA refers to them, and when they refer to them, they're expecting that you know the requirements of those, because that's what they're going to cite against as practices for confined space, even though it may not necessarily be written into the OSHA standard itself. Again, we probably all know that if they don't have a standard for it, they will just go to the general duty clause if they recognize a hazard and cite us under that. They rely on you from a responsibility standpoint to understand what the ANSI standards, because they're not necessarily regulations, they're standards, but OSHA views them as regulations for the prevention of incidents and abatement of hazards and things like that. So they'll use them as regulatory at that portion. As far as reviewing the letters of interpretation, you can review them, but there may not be letters of interpretation on everything, because that just is somebody actually wrote in and did an interpretation, or OSHA saw something throughout. So You can rely on them, but don't use them as gospel, or if there's no letter of interpretation, okay, I'm just going to go do this. Look at it more from a standpoint of evaluate the hazard, determine what you're going to do to take care of the hazard. OSHA's really looking for the hazard assessment piece, that you understand the hazards and have some way to control the work of an employee who's interacting with those hazards and protect them from the exposure to that hazard.
Okay, it looks like I have one more question for you here, Andy.
Okay.
Is it true that an entry permit may be suspended and then reinstated upon a reinspection?
Yes, and it depends on the circumstance. So, for example, one of the programs I've built in the past, say the fire alarm goes off and people have to exit the building while they're doing this confined space work. Permits become null and void because you don't know what the emergency was. Even if it was a false alarm, you still then have to go back in and reevaluate that. So what I generally advise is, if you cancel a permit, restart the process with a new permit. Document why you canceled it. The entrant and the attendant and the supervisor can suspend that permit at any point in time, pull people out. Depending on the situation, it's really a decision point. Do I need to, can I continue work in there under the same permit, or do I need to cancel that permit? And it depends on the situation. There's other questions that I get from time to time around permitting. I'm not necessarily going into it, so can I classify that space as a non-permit entry? You still have to do that hazard analysis and assessment if you say, well, I'm going to go into something that was deemed a permit-required confined space, but I'm going to temporarily make it a non-permit required confined space. It requires the analysis to be able to do that.
Good. Well, thank you, Andrew, very much. Yes. And thank you to all attending today's webinar. In the near future, you will receive an email directing you to a replay of the webinar and the associated documents. Also watch your email for announcements about future webinars, and be sure to visit the ASA website at www.asa.net. We appreciate your participation today, and have a safe day, everyone.